Greetings and salutations to all the dignitaries present here. We Team Astra are here to present our final design report. Our team is of 42 cooperative members who are divided into 11 teams with different roles. Myself, Kishore, Aravind, Asif Muhammad, Surya, and Shailesh are here to carry out this presentation. Why design? Drawing is a basic mode of communication, so this communication depends upon the drawing which we do before fabrication. This acts as a bridge between the manufacturer and the designer, hence it can also be used for further development of product. Next one is application. It depends how the idea is getting implemented in practical life without any harm to human lives. When these communication and applications are maintained in a proper scale, it helps to mass production of the product. And the ultimate and the important factor that to be considered before manufacturing is the need and its advantage in real time. So as we use solar as our primary source of energy, it gives a window for not using fuels that causes a bad atmosphere. This is the prototype model. This is the prototype model which was made by Team Astra for the better understanding of design. With the help of this, we made the final changes in our final design report. Here are our basic informations of a cart. It is wheelbase of 64 inches and track width of 42 inches with golden ratio close to 1.53. The pipe material used here is AASA 4130 with outer diameter 1 inch and thickness of 1 mm. Our team has preferred 4-wheeler cart because to overcome the space capacity issue in solar panel mounting. Next, a firewall is between driver and motor batteries to ensure driver and motor batteries while the connection of malfunction while we have malfunction connections in electrical circuits. The weight distribution front is to rear is 40 is to 60, and hence it has the total fabrication weight of 250 kg including components with driver. The fabrication has strictly followed these 5 steps. Rigid structure. It can withstand heavy loads in deformation of a roll gauge and to avoid accidents. Driver safety. As we said earlier, we have a firewall to protect drivers from batteries and motors. The driver is protected with a 5-point harness seat belt. Suspension. To avoid maximum deformation of the components of the driver when cart moves in a high velocity on an uneven surface. Versatile steering is to make it easy for the driver to control the direction of the cart in an easy manner. Harness solar to observe the universal energy and converts it to kinetic energy to move the cart. When it comes to material selection, we have 4 different types of ASA materials that are American Iron and Steel Institute materials 1080, 1018, 1020, and 4130. We have chosen 4130 because of the features, that is high tensile strength of 460 megapascal, which supports low elasticity, high rigidity with molybdenum of 0.22%. As it is rigid and tensilable, the deformation is low and factor of safety is high. And also the amount of carbon content is about 0.3% that supports stick welding easily and makes easy for the machinability process. And also it has better cost when compared to other things. These are the views of a roll gauge: isometric view and side view. In this view, we assure that we have maintained proper triangulation, and we have also followed the guidelines properly. Uh, ANSYS analysis. When it comes to ANSYS analysis, the SUVC team has asked 5 different types of analysis: front impact, rear impact, side impact, torsional impact, and drop test. When it comes to front impact, rear impact, and side impact, we were asked to give 3G forces, where a G force is mass of the whole cart into gravitational force and 3 times of it. And these 3G forces were tested on the bulkheads of front and rear bulkheads of the chassis for front and rear impact respectively. And for all these 5 analyses, we have maintained a proper machine size of 10 mm. Side impact, one side of the chassis has been fixed and other side the force has been applied. And when it comes to torsal impact, the coupling forces were given on the members of the chassis, and the deformations were observed. The deformation is about 0.8 mm for a maximum scale. The drop test was performed in 3 meters, and the analysis report has been presented here in the bottom. And the maximum deformation for this drop test is about 0.29 mm maximum deformation. And this is the total assembly view of a cart, which shows the total hub, suspension, tire, steering, seat, and all the peripherals.
Suspension. Not every surface in the world is smooth and narrow. Suspension is an important part of the automotive industry that connects the tire to the chassis. The suspension system is used to isolate the impact of the road conditions to not only the car but also the driver. Suspension increases the friction between the tire and the road, which ultimately increases traction. The suspension system is made up of several components, which supports the weight of the vehicle and absorbs the road shocks and craters with the help of shock absorbers. Suspension system play a major part in the steering. A good suspension increases the comfort of the steering. The suspension also controls wheel alignment, vehicle roll, acceleration, squat, etc., and maintains the geometry of the vehicle during the entire travel. There are different types of suspension systems, such as McPherson's suspension, leaf spring suspension, trailing arm suspension, double wishbone suspension, etc. Based on the research on various types of suspension and rulebook conditions, double wishbone suspension is chosen for front and rear. As the name indicates, double wishbone suspension consists of upper wishbone and lower wishbone that connects the tire to the chassis with the help of knuckle and wheel hub. By considering the driver's comfort and minimum ground clearance of the vehicle, the suspension system is designed according to the suspension geometry. After several iterations on the Lotus software, the final values for the suspension systems are taken. The shock absorber is made up of spring and damper. The calculations for the spring is derived by considering the force acting on the spring and deflection of the spring. After several iterations, the final values of the spring is also calculated. Steering. Steering is the key aspect for overall handling and stability of the car. The steering system is used to guide the vehicle. A good steering system is that the driver can sense the front tires. The steering should be responsive enough for high speed and low speed turning. The steering system converts the rotational motion of the steering wheel into swerving movement of the wheel. The major factor for designing the steering system is the geometry of the system. There are various types of geometry such as Ackermann, anti-Ackermann, and parallel steering geometry. Ackermann geometry is chosen because of low speed turning. The steering parameters such as caster angle, kingpin inclination, scrub radius are considered while designing the steering system. The rack and pinion system is chosen for a part. The rack and pinion system consists of a circular gear and a linear gear that converts rotational motion into linear motion. This system is selected because it provides a lower steering ratio and better stability. Vehicle wheelbase, track with kingpin inclination, and wheel inner turning radius are taken in account while deriving the calculations for steering system. The steering system for the above calculations is similar to the help of Lotus simulations. After several iterations, the final values for the steering systems are derived.
The braking system converts kinetic energy into thermal energy through friction between pads and disc to stop at a minimum distance. It consists of rod 4 brake fluid, tandem master cylinder, floating calipers, transmission hoses, metal tacks, pedal, brake over travel switch. Dot 4 is a state of the art high performance premium brake fluid of outstanding quality with a high wet boiling point and thus extremely safe reserve against vapor lock. It possesses features like high boiling point, minimum rubber component swell, excellent corrosion protection. It also offers consistent and safe brake performance under severe braking pressure. It reduces leakage and loss of fluid to a minimum. It also extends the life and reliability of the brake system components. These are the calculations that we carried out to find our brake parameters. We were really careful to adhere to the rulebook in every circumstance. For instance, the brake pedal force is expected to be at 1791.1 Newton, while it can withstand more than 2000 newtons of force. Transmission is the most important component of a vehicle, and it helps to transmit power from the motor to the wheels. Speed and RPM of the wheels can be controlled by ensuring that the right amount of power is gained by the wheels. It can be used to change the direction and magnitude of parameters such as speed or torque. A mechanical shaft is a mechanical power transmission element that conveys power and rotational motion from one device to another. Couplings are also known as shaft couplings, are used to connect two shaft ends together to transmit both angular rotation and torque. The main design requirement for couplings and their retention devices is that the rated torque must be transmitted without slip or premature failure. In some cases, it needs to withstand even misalignments. Chains are used for low-speed applications where the distance between the shaft is too far apart to use gear trains, and belts are going to support the torque that needs transmitting. They are also a good way of transmitting power when exact speed ratios are needed. The differentials are used to provide differential speed to both wheels. This will prevent slipping of the wheels while turning, hence there is less load acting upon the motor. Here are the calculations for our transmission values. Our maximum speed is 55 km per hour, which is below the maximum speed specified by SUVC.
Battery. As per the rule book, the voltage of the battery doesn't exceed 60 volt. We have been planning to choose a lithium ion battery which has high efficiency, high energy density, fast charging and low maintenance. The electrodes commonly used in lithium ion batteries, lithium and carbon, are lightweight and are worn compared to other rechargeable batteries. Lithium ion batteries can be safety hazard since they contain a flammable electrolyte and may become pressurized if they become damaged. The major difference between lithium ion and lead acid batteries are charging a lead acid battery can take more than 10 hours, whereas lithium ion batteries can take from 3 hours to as little as a few minutes to charge, depending on the size of the battery. We have installed battery management system which is not only used for monitoring the life of a battery but it also functions to protect the battery while in operation. The calculations for choosing a battery for a vehicle are as follows. To run a 2500 watts motor at 60 km for 1 hour, we need 48 volt 65 Ah battery. We know the formula power is equal to voltage into current. By using this formula, we can calculate the current which is 52 ampere. After calculating the current and also wanting to know the ampere rating in 1 hour, we calculate the power utilized in 1 hour and divide it with the total voltage. We will get the current usage in 1 hour. Finally, we gain 65 ampere hour of a current rating by calculating it. If we drive a vehicle for a long time, the battery will get discharged. Then the discharged battery can charge around 6.09 hours. Motor. Here we use BLDC motors that have higher efficiency and long operating life. It will convert more electrical power into mechanical power compared to a brushed motor. Due to the absence of friction of brushes, it provides high torque with better speed control and efficiency. We use a motor controller for BLDC motor, which is a set of devices that help in regulating the manner in which a motor works. The controller is also able to engage the motor into forward or reverse rotation as well as regulating and limiting the rotary speed, torque, and protecting against electrical fails and overloads. For moving a vehicle, it overcomes three resistance forces: one rolling resistance force, two gradient resistance force, three aerodynamic resistance force. Rolling resistance force is nothing but the resistance that acts between the tires and roads. Then the power required to overcome the rolling resistance force is 327 watts approximately. The gradient resistance force occurs when the vehicle is driving in an uphill or downhill road. There are no slope areas in our place, then the power is zero. Aerodynamic resistance force is offered only by air. Based on our calculations, we can get the value of power to overcome the aerodynamic resistance force is 2013 watts approximately. Finally, after adding these three powers, we acquire the total power required to move the vehicle, which is approximately 2500 watts.
Solar, which is the most important task in our car. We planned to use a monocrystalline solar cells instead of polycrystalline because it has high efficiency, long lifetime, very strong, high output compared to polycrystalline. And monocrystalline solar panels are characterized by their black PV cells with rounded edges. They have a high conversion efficiency than polycrystalline panels, which means they produce more kilowatt hours of electricity. As we search in market, we can't find expected product based on our dimension. So we approaches the solar manufacturing place to make a panel on our required dimension. Here, the electrical characteristics of solar cells. Each cell in a panel produces an approximate maximum power of about 4.36 watts and has a maximum voltage of about 0.53 volts and maximum current of 8.22 ampere. Based on our dimension, we need a maximum of about 28 to 30 cells per panel. So the output coming out from the panel is about 130 to 150 watts approximately. We team Astra planned to fix about 4 to 6 panels in our card, so the power will become 780 to 920 watts approximately. Uh, in in solar panel, every panel needs a charge controller, so we move into the MPPT charge controller. First thing, how to select a charge controller. We all know the general P is equal to VI formula. By using this formula, we are going to calculate the current rating. By calculating the current rating and multiplied with the safety factor, we gain the charge controller rating. By calculating this, we get an approximate of about 20 amps. Here we have a 50 amps controller, so it is more easy to deliver a maximum power to the loads with minimum losses. Flow diagram. Here the PV array and MPPT controller and a converter are connected to a battery. Next, from the battery it is passed to the subsystem which acts as a motor controller. By this connection, the energy from the panel is transferred to the charge controller, and charge controller it is transferred to the battery, and from battery it sends to the motor controller, and the motor controller transfer the energy to the motor, thus and the motor starts rotating. In solar round, we want to move the car directly by getting the energy from the solar panel. By analyzing all this, we make a flow diagram according to that. We, the team Astra, thanks SUVC for giving this wonderful opportunity.